Today we are going to have a look at bivariate exploratory data analysis. And last week we did univariate, where we are dealing with only one variable. But today we are going to deal with two variables and how we can identify relationships between two variables. For example, this will be done today. And what we have on the agenda is we want to draw a scatter plot, which is going to be about the relationship between quantitative variables, but we can also do it by grouping. And we are going to have a look at what an heat map is about with regards to categorical pairs and also correlation as well. We are going to have a look at faceting, where we are going to compare patterns across subgroups. All these are on the agenda. So by the end of this class, you should be able to create scatter plot with grouping as well to explore bivariate relationship, be able to build and interpret count heat maps for pair of categorical variables, compute and interpret correlations for numeric variables, visualize correlation matrices as heat maps, and spot multicollinearity, and finally use faceting to compare patterns across subgroups. That's basically what we want to do today. As usual, we'll start by a first part of the video where we are going to use R to run these different graphics. And the second part of the video, obviously, would be to use Python to run these different graphics. So, today we are talking about, we are already opening R and start to work on it. So we will do bivariate EDA. I'm going to share this with you later on. And we are going to explore the relationship between two variables at a time. Just give me a second with you. I'm just going to save that script somewhere. Um, Yes, we are going to run the different methods that have different graphics that I mentioned to you. I'm not going to come back on that. And for that purpose, we are going to need our packages. So we'll start by loading our packages. What are the packages that we will need? We will need two main package, of course, the ggplot2 package, and you will need the dplyr package. All right, the ggplot package is obviously for plotting, and the dplyr is for simple data summaries like counts that we are going to do later. Okay. Now let's start by the next step, which is to load our data set and talk about the data set briefly. Here we are going to load data set. Okay, first of all, to understand the data set, let me just show you the data set here. This is a dataset that I'm going to use, and it is already available on Google Classroom. This dataset is a small synthetic customer style dataset, and it is created for running the bivariate exploratory data analysis, right, that we have here. Each row represents one observation, like one customer record, and we will use it to study how spending relates to income, uh, and how patterns differ by segment or channel, right? How patterns differ by segment or channel. Now, to be able to do so, we are going to read that data frame, and obviously it is within a path called read.csv that I'm going to use. All right, just to make it easier, I've already the code somewhere. I'm just going to copy and paste that. Just give me a second with you. I'm just going to copy and paste the code. Here we go. I guess this is something that you are used to by now, how to read the data in CSV. I'm not going to take too long on that. I'm just going to move on. And we are going to run that. And here we are reading our data set and loading it. Okay, what are the variables in the data set? You would have noted that there are quite a number of variables. Some of them are categorical in nature, like these, and the rest are quantitative in nature. All right, I'm not going to spend too much time on that. You will see that there are different segments like customer category. You have those budget category and standard and premium category. You have channel, which is a purchase channel, which is either online or store. You have a region, which is the region label, whether north, south, east, west, and the rest is quite easy to understand. The age in years, the income level, and the expenditure amount, and we assume that it is rupees for the time being, and it is tenure months, how long the person has been a customer in terms of months, and also satisfaction. That is, it's a score on from 1 to 10. Okay, so let's do a quick inspection of the data. If you want to have a look at the data, you can do a quick inspection. Like, to do the quick inspection, there are quite a number of things. We have already loaded the data set. By the way, I did not load the package. Let me run the loading of the package first, and then we can move on. Otherwise, there are certain things that won't work later on. So we'll read the data set that I've already done, and the next step is to do a quick inspection where I want to check the size, the first rows of the data and data types as well. So to do that, we can do dim of df, which is going to give me the number of rows and columns that I have in my data. So you have 300 rows and 8 columns in the data. And you can do the add of df just to have a quick view of what you have in the top of the data, which is what we already seen in this in the Excel sheet. And then we have str data just to get the structure of the data. And this shows each column type like numeric. You will see that there is character, etc., etc. Okay. Now, we do have a problem here. As you are seeing, these are treated as character when they are supposed to be treated as factor. We will need to deal with that in a moment. And by the way, if you do summary of df, you will observe that when you do summary of df, these are not properly represented because they are considered as characters. So what do we need to do? We need to do some adjustment to the data. So we need to convert character variables to categorical variables. To do so, what do? We have to use a function. There are quite a number of ways because they are already labeled clearly, as you would see here. They are already quite well labeled: standard, budget, online, etc. They are not numerical, so there is only one simple piece of code that you can write to convert everything. It's as simple as dot factor. You can just run that piece of code, and we have three variables here, so I'm going to run this code 3 times. And here we are going to have our df dollar. That is because I did not attach the data yet, so I'm going to say df dollar. Sorry, just give me a second review. Yes, df dollar, and df dollar will be, you are converting one variable, which is segment that you are seeing in the console down there. You are converting one, which is channel, and you're converting the other one, which is region. They are character, and they will be converted to these categorical variables, and you are going to replace them within the same variable. That is, you are going to override them. We are not going to create a new variable particularly to describe that. We are going to override them immediately. That makes things far straightforward because we are going to use these same variable that have been overridden to work with, and you can just run those. And here we go. If you want just to have a look at str of df now, you can just check it quickly. Str df now has changed from character to factor, which means in the term factor here means basically categorical variables. All right. These are how you convert into categorical variables and the levels of budget premium. By the way, if you wanted to have more information pertaining to the levels, how many levels do you have, things like that, what are the different levels, you could write the levels, the F dollar segment. If in case you're not seeing, but you already know it, but let me just show you that. So then you get the levels for segment, because here you see only premium and budget in the preview, but you don't get the full picture. So if you want to know what are the different levels within that categorical variable, then you can use that particular code here. And you can do the same for the others. But let's move on directly to what is of interest to us. We'll start by the scatter plot. Now we can do a simple scatter plot in R using the base version of R, but I'm going to use ggplot to be able to do that, by the way. So what is the scatter plot that I'm going to do? I'm going to have income, which is going to be my independent variable, and I will have spend, just like we did last time, which is our expenditure, versus income. And what do we want to do is to have them colored by segment. That is the second part of what we want to do. We want to draw the scatter plot, and then we want them to be colored by segment. That is, we want a scatter plot specific for expenditure and income for different categories of segment. Okay, so the x-axis will represent the income, the y-axis will represent the numerical variable. And what do we want to do within the scatter plot is basically to look at the direction, whether it is going to be an upward type pattern or whatever. We are going to observe outliers or group differences. These are of interest to us. Let's have a look at how we draw the scatter plot. I believe by now, I believe normally at this level, you already have an idea of what a scatter plot is. Okay, it basically enables us to see the relationship that we have between two quantitative variables, and each dot in a scatter plot represent an observation. So maybe the best way to explain what a scatter plot is to draw it, and then you'll get a better appreciation of what it is, rather than me just explaining it to you, right, telling you what a scatter plot looks like. So I prefer just to draw it, and then you will get the better appreciation of what it looks like. So we'll run the ggplot, and as you already know, in the ggplot, you will need to start by your data, and then you will need to put the aesthetic features of your ggplot. We have in our x-axis income, which is used, all right, in under df. X is our income. We know that y is spend in our case, and we also, if we stop there, there is no problem. We can stop that code here, by the way. But normally, as you would have seen here, I want to color them by segment. That is, I want a scatter plot based on different segments, okay? But if I stop here, that should be fine. For example, I can start already by saying plus, and then I say j on points, because if I'm doing a scatter plot, I will need to use that function called point, okay? And in that geom point, I will write down something I will show you in a moment. But first of all, I could stop here, but also I could add, as I said to you, a new segment to it, a new segment, not a new segment, a new parameter, and that parameter would be segment. That's something that I can do. But I need to differentiate the segment by color. So I will type color equal to, and then segment. When I'm doing that, it knows that all of these variables will be found in df, and then it will give me this scatter plot based on these different segments that you have in your data. But then there is something else that I want to do is alpha equal to. I put alpha is equal to zero point 0.6. What does this mean? Normally, when you say alpha is equal to zero point 0.6, it means that you have a partly transparent point. If alpha is equal to 0, normally you would have a point that is fully transparent, which is invisible basically, and you don't want that. But if your alpha is equal to 1 now, you have a fully opaque and solid point, which usually is what you do in the traditional setting. But me, I'm just showing you that you can make your points a little bit transparent. You can play around with this figure if you are interested in doing so. Otherwise, you can leave it as default and it doesn't matter much, which is going to be then alpha is equal to 1 normally. So then you can add the labels as usual, and the labels, there are quite a number of things that you can do. For example, you can put a title to this graph, and we will call it a scatter. Uh, Yes, by segment. So scatter, where we will call it spend versus income, and we'll say it is colored by segment, right? Colored by segment. So here we can't write color as it is here because we are using the English system in writing, but in the coding it's the American system, so we need to write color as it is here. And then you put comma, and then you will put your labels. For example, x equal to capital income, because income is small letter, you can put it as capital here, and then you do comma, you say y is equal to spend, and then you close. And then there is something else that I want to do. You will see that generally if you don't add what I'm going to show you here, you will get a graph where there are going to be quite a number of grid lines and a background behind, which is not very nice. So you can just put theme underscore. I just explained that in the previous video, so that's why I'm going a little bit fast on that, because it's something that I already mentioned. So if you don't want to run it up today, I'll just show you what it looks like. Okay, so you can just run it there. You will see that there is this dark gray background that you don't necessarily want, and you can improve it by adding this theme classic. So I run the whole thing again, and then now you see that there is the how do we say, the classic theme that you are used to. And here we go, you have your colored points. By the way, you may wish to play with that. Let's suppose this is a little bit too opaque. Let me just move that on this side and this here. If you want to play around with those points and get it a little bit uh, like opaque, completely opaque, you can put it as one, by the way, or you can put it whatever. You can leave it as default, and you run that again, and you will see that these are darker and more opaque as you're seeing. It all depends on what you are looking for. And as you see here, the advantage is that when I'm coloring by segment, I have an idea that there are some clustering going on. The red uh, segment seems to have lower expenditure and lower income, generally the budget, and the blue one seems to be standard a little bit in the middle, income group and expenditure group. But we have green ones which tends to be on the upper side of income and upper side of expenditure as well. And these are the premium groups as you are seeing. That's the advantage of drawing a scatter plot, and the advantage that you have here using ggplot is that you can include an additional segment and a condition, I mean, on a categorical variable that you want to include. And that's what we just did here. You are doing that through an additional parameter called segment. You get more information, obviously, when you do that. Okay, that's the advantage. If you just remove that for a moment, let's just remove that and then run the whole thing again. You will see that you will just get those points as they are. You just see that there is a positive linear relationship between expenditure and income, but it does not bring that much information than if you were to do this additional, this additional parameter here, which now includes the points being colored by segment. And then this gives additional information, and that's kind of graphic that you want to give you more information. So let's move on. So what we just did here is scatter plot. Okay. The next step is to do a faceted scatter plot. All right, let's do that. Faceted scatter plot. Now, what is this faceted scatter plot? I want to be the scatter plot to be split by channel. Right, a different channel online, or I forgot the name here. Let me just check that quickly. It was online or store, yes. I want the scatter plot to be faceted. Now, what is faceting, by the way? I'm just going to note it down here because you may not be used to this one. That's why I'm going to take some time. What is a faceted plot? Okay, that's what we refer to as faceting. What is faceting? So I'm just noting it down here. When we talk about faceting, faceting means splitting one plot into several smaller plots that we refer to as panels generally. And so faceting means splitting one plot into several smaller plots, which we refer to as panel, using obviously a condition, a categorical variable. Now, note something. The condition here is based on a categorical variable. You see, that's something very important. It is based on a categorical variable. There is something, another concept that is a bit similar to this, what I'm just mentioning here, which is Trellis graphic. But well, let's stick to what I'm talking about here, faceting. And what we want to do here is each panel each panel in this graphic should show the same type of plot but for different subgroup. Each panel shows the same type of plot but for a different subgroups. I said to you, there is for a different subgroup rather. There is a concept that's relatively close to that, which is called Trellis graphic or lattice plot. And there are packages that you can download as well to run Trellis graph. But in ggplot, you can do faceting, by the way. Why do we need to do faceting? Because we want a relation, because the relationship might look different in different groups, obviously. That's why we want to look at faceting. For example, here, the relationship within segment seems to be more or less the same all over. But sometimes, if for a different categorical variable, things might not necessarily look the same. You might have a different gradient or a different observation of a relationship within different groups. All right. So here we ask, is the income and spend pattern? So what are we trying to do here? We are trying to say, is the income spend pattern the same for online versus store? That is my idea when I'm doing the setting. And let's start to do that. To be able to do that, am I going to do faceting? A Let me start by the ggplot as usual, and I'm going to keep the same thing that I did earlier. I will keep that. I will again bring that as it is here, the jump point, because it still consists of jump points, so we are not changing that. So we have our color by segment, because segment you can still color it within a different groups. You can see additional information pertaining to segment within the two different groups of online versus store. You can see whether the segments shows the same kind of relationship that it is overall here within different how to say channel. And then what you can do, by the way, as I said to you, you can play around with that. Let me play with it by putting 0.9, for example. And then you start doing your faceting. That is, if you just do that, you will get the same graph like we did earlier. But now the only difference that I want to divide it into two different panels. One panel will be for online, one panel will be for store. So how do I do that? I need to run a code, a function that we call facet wrap. And that facet wrap, you need to state on what condition it's going to do the faceting. The condition here is to have two panel, one panel of scatter plot for online, one panel of scatter plot for the store. So to do that, we do tilde and then we do channel. Generally, that's how we go ahead by doing facet wrap for a single categorical variable based on one grouping. All right, I'm not going to extend that further to more groupings here. You can investigate it yourself later on, because this tilde is used if you are taking only one categorical variable on which you are doing the condition. But if you have more than one categorical variable on which you are doing the condition, then you might have a grid. Instead of having only two panels, you might have a grid where you have different rows and columns for different variables if you have two variables. And then you can choose which one you want on the row, which one you want on the vertical by placing the other variable here and the other variable here. So it all depends on what you want. I'm not going to get into further details on that. I'm just going to stick to what I've just shown you here. But if you want to go on further on that, you can just investigate what facet wrap can do, and you will see if for your assignment you want to do something additional, you can do that. So let's move on. We have now to add the labels. What I will just do is that I will bring all these together because these are going to be similar. And the labels here, I'm not going to use the same label, but I will call it faceted scatter. Faceted scatter plot. Okay, I'm going to call it faceted scatter plot, uh, colored by segment. Oh, maybe I will remove that. I will put it now. Uh, separated, separate panels by channel. Okay, I don't need to put that, by the way. You could just remove that if you wish, but I'm just keeping it here for the purpose of when we are looking at the code, you understand what's going on. But there is no need for you to put that. You can just put faceted scatter plot, spend versus income. That would be sufficient, by the way. Okay, we are going to talk about now heat map. Okay, a heat map of counts. Heat map of counts, where I'm going to take segment versus channel. So here we are dealing with two categorical variables. You see the difference between what we did earlier? Spend and income are both numerical, and you have just faceted it by two different mm, channel. But here I'm looking at the heat map of counts. The question is, what is a heat map? A heat map is a grid of colored tiles. Okay. What we do is that we usually often use it to summarize values in two-dimensional tables. One category on X, another category on Y. The color intensity represents the size of a value. The color intensity represents the size of a value, like for example, a count. Okay, if there are more count with regards to, let's suppose, online and budget, if there are more counts in online and budget compared to the others, obviously the color will be darker for that particular group and subgroups, I mean. So that's what is a heat map overall. And the x-axis that I'm going to use here will be channel, and the y-axis will be segment. But you could play around with that. You could have put the y-axis to be channel and the x-axis to be segment. It does not matter much. Okay, it's the interpretation that you make out of it that matters. So what are we going to do to be able to do the heat map? Just like we did in a bar chart or any other graphics that includes categorical variables, we generally compute a count. Okay, so we are going to create a frequency table. That's the idea. We want to create a frequency table with, in more precisely, a contingency table. In my case, a contingency table is also referred to as a cross tabulation, where you got the counts with regards to the different combination of segment and channel. To be able to do that, I will need to use a function called count, but I will apply that on my df, on my data frame. To be able to apply that on my df, I will use a piping operator, which is, as you have already learned it in the first semester, the pipe operator. And what we are doing here is that we are applying a function count on the data frame. And this piping operator, by the way, it will come only when I've loaded the deploy our package, which I've already done so earlier. Let me just check. Here we go. It's already there. So we are going to use this pipe operator from the deploy package. And in that count, that is this frequency table, what I'm going to do, I will put the two variables that I want. I will have segment and no, segment and channel. Now it doesn't matter which one you want to put first and second. Uh, it's all fine. You will get the same interpretation in the end anyway. And I will just give it a name. I will call it count SC for segment channel. And then I can execute that, by the way. And then I can just execute that part here, and you will see that there is segment channel here. So if you put channel segment here, that would change obviously. But what matters is here is that you see that standard online and budget online seems to be the group where you have more counts in that data, and the count with the smallest number of client is premium store. So you have far less people who are from premium that visit the store, who are for premium and visit the store, in that data set. So the next step is to get into the plot directly. So to do that, let's say ggplot, but now the data is not df, but rather counts sc, all right, that we just wrote here. Count sc that we just wrote. And this, we will have the aesthetic features. Obviously, we have your x, which is equal to, and your y, which is equal to. And the x, I want it to be a channel on the x, so I put chap, no. And the y, I want segment. The next step now is to add an additional parameter, which is fill equal to n. What is fill equal to n? Fill equal to n means you fill control the fill here. Normally, it will control the color of a tile based on n. When we say equal to n, it means based on the count. N represent count. So it is going to fill color based on the count. That it is not filling color by something else, which may be percentage or whatever, but it is filling by counts. That's what we are doing. So this is an additional parameter that I'm setting in there. When the tile will be drawn, it will be drawn based on the count. That is, the colors would be drawn based on the count. And for doing a heat map, we need geom, but this one is tile. All right, it's going to be tile. Then we can do plus, and then we can add some elements in the tile. Because if we just draw the tiles without the elements of the count, we will just see which groups and subgroup has the highest count, but we will not know what are the counts. We won't know whether it is 69 for budget online. We just know that it is the highest and this one is the highest, but we won't know how many counts we've got. So if you want to include those counts, we need an additional layer here, which is called geom text. Geom text. So we are going to add text within those things, and the text will be based on the label, and the label will be the count that you have for each of these. You see the n here, the count that you have. This is going to be the label, as I mentioned here. Fill is equal to n, the count. So you will get this information, and then you can just decide what color the text can be. It can be white, it can be black. Let me just try white for a moment, and then we can try black later. And then we do plus, and we need the lab, obviously. So let me just try this again. As usual, I bring that down there. So the lab now, the title will be heat map based on counts. Okay. And this is by channel, segment by channel. And the X is, as I mentioned to you, channel, and the Y is segment. With Sim Classic, I like to use it, as I mentioned to you, because we avoid all these dark gray background or anything that is irrelevant. So let's execute that. And here we go. We've got our heat map as you are seeing. There's one thing that you need to pay attention to here is that you need to pay attention to that legend here, where you see that the more dark the tile becomes, the lower is the count. Generally, you would expect that the darker it is, the higher the count. But in that particular setting here, you have to be careful because by default, what is happening is that the darker it is, the lower the count. Like here, you can immediately spot that individuals who are from the premium segment and in store seems to be lower for that particular data set compared to people who are from online channel with standard and budget segment. So for this particular online store, for this particular store, normally you will see that standard online, that is standard segment uh, and budget segment from online channels seems to be the highest. We have more clients from these two different subgroups as you are seeing here. Okay, so if the company wants to uh, improve its strategy, it can work on these two groups and also the group where there is lower value as well. So these are the heat map as you are seeing. Okay. Our next step would be to draw a correlation matrix. So that's what I want to do, and not to draw, but to obtain the correlation matrix, but also a correlation heat map. You already have an idea of what an heat map is. Correlation, you already probably know what it is. Okay, correlation normally measures the strength of linear relationship between two quantitative variables. And the correlation that we are going to use will be the Pearson product moment correlation. And correlation lies between -1 and 1. And that is what we are going to use. I would suggest that you go and investigate a little bit about what a correlation is, more precisely the Pearson product moment correlation coefficient. And we want to obtain, so but still I just mentioned briefly, when you have a correlation where you have a value, normally correlation lies between -1 and 1. Any value that lies between -1 and 1, uh, like if it is, for example, 0, you would say that there is little or no linear relationship at all. No linear relationship. But the moment that it lies closer to 1 or closer to -1, then the relationship becomes stronger. If it is closer to -1, it becomes stronger. Negative, there is a strong negative linear relationship. If it is close to 1, there is a strong positive linear relationship between the two variables that you are measuring. That's the main idea between correlation. And what we want to do is that we want to select a number of variables. We are not going to draw a scatter plot, or not scatter plot, a single correlation, but we are going to draw a correlation matrix with regards to several variables. Obviously, that's why we call it a matrix. And the correlation matrix, it contains correlation for many pairs of variables. So if you have 5 numeric variables, you will get 5 by 5 matrix. That is, you will have 25 correlation figures that will be computed. And what is a correlation heat map? As I was mentioning, it is a heat map where E is going to be where each tile that you saw earlier when I was doing count, now each tile will show correlation between the two variables. They won't show the count, but will show the correlation. And the color represent the correlation values, obviously, from negative to positive, things like that. So to start with, let's choose our variables that we want to select. We want to select, I'll call it numDF, because these are numerical variables. When you're doing correlation, you do correlation on numerical variables. You don't do correlation on categorical variables. And then you are going to apply the function select on your DF. You're going to apply your function select on your DF, and you need to choose the variables that are of interest to you. And the variables that are of interest, if you recall strdf, let's run that, you will see these are the variables that we have. So we can choose among all these variables. So we have age, we have income, we have spend, we have tenure months, and we have satisfaction. All of these we will use within our correlation matrix. So we'll just type this down: income, spend, tenure month, satisfaction. We'll type this down, and this is what we do. We have selected this, only these columns within our data frame now, as you are seeing right now. Here we go. You see that we have selected only this to create our matrix. So we are going to create our matrix based on numerical variables. The next step is to compute the correlation matrix that I was mentioning. To do the correlation matrix, I'll just give it a name, co-mat. I repeat, these are names. You can change them as you wish. And then you do co, which is a very simple thing. And then you do df, co of numDF. This is a very simple function. And then you can run the core matrix to see the correlation matrix as you are seeing. So for example, age and age, the correlation is 1, obviously, but the correlation between income and age is relatively small with 0.27, but the relationship between income and expenditure is relatively high, showing a strong positive linear relationship between income and expenditure. Okay, now if you look at expenditure and income, you expect to get the same correlation as you have here, obviously, because just the position of the variable in the matrix that has changed. Otherwise, the correlation stays the same. It's not expected to change as you are observing here. And the tenure month and income, you should expect to have the relationship being the same as if you are computing income and tenure month, as it is here, the same thing. That's just for information. So somehow, some of this information, if you want, like the lower diagonal, becomes redundant. Or when you have the upper diagonal, that is sufficient to determine what the correlation is about. But let's leave it as it is for the time being. So you have understood what the correlation matrix is about. We are going to get directly into drawing the plot of a correlation map. But to be able to draw the plot of a correlation map, you see that this is a matrix. I would like to make my data, or to convert my data into a long format. A long format to be able to apply the ggplot heat map. To convert into a long format, as you would realize, what do I mean by a long format? It means that the same structure that you are seeing here will change into variable 1, let's suppose, variable 2, and the correlation next to it. So for example, variable 1 means you have age. The correlation is going to be 1. And then variable 1, let's suppose, for the row is now income. But variable 2, you can still work with, let's suppose, age. So we put it like this. We have here variable 2 age. And now the relationship is the correlation is 0.2754, and it goes on like that. So I want to convert that into that kind of format to be able to draw that um, heat map. Otherwise it won't work. I can't draw the heat map directly from that matrix like structure as you are seeing. So to do so, I will say colon, and then I will say as dot data frame. When I'm doing that, I'm creating a data frame. Data frame, by the way, in R means that you have a set of columns in your data and rows, obviously, but the columns can take different data types. That's why we talk about a data frame. For example, in matrix, all are numerical, but in data type, you may allow yourself to have different data types for information. But here, what you are doing is that even though we are not interested in several data types, we are still interested in only the income, the correlation to be a single data type. We still have the variable that needs to be included. For example, variable 1, variable 2, that is the second column, and variable 3 is not variable 3. The third column is score, but you still need to include here names of these different variables, like age. All these are not quantitative in nature, so that's why we create a data frame that includes all of these together. That's the only way to include that. And then we say as dot table co mat. What does this mean? Right now, the correlation matrix is in a structure of a matrix. When you did that, the structure of a correlation matrix is a matrix. So what do you need to do? You convert it into a table, all right? When you're doing that, you can then create your data frame from that table. That's a small step that you want to do, just for information. And then you need to pipe that onto um, a new set of names. For example, if I stop here, you will see that columns gives me these variables, variable var1, var2 by default, and frequency. Now, generally, we are not working with frequency, but by default, normally, when you're converting to a data frame, that's what it does. But we don't want to call this frequency because that does not make sense. This is a correlation. So we want to change this, and we might want to change that as well if you want, the var1, the var2, or you can keep it as it is. But I'll still show you how you can change that if you want to do so. So if you want to change these different names, you will need to put the name that you want first. The name that I want, I suppose, instead of var1, I want it small letter var1. I put equal to what it is by default. It is by default capital V AR1. And then I want the other to be var2. And by default, it is VAR capital VAR2. I don't want frequency, but I want it to be appearing as core. That will indicate that it is a correlation. So the matrix will change to core because these rename variable will help us when we are drawing our heat map. These names will be present there instead of having names like frequency that would not make much sense. So you take the default, which is on the right hand side, and you replace it by the new variables that you want to call them according to the name you wish to call them. Okay, so that's basically what we are doing, and we can just run that if you want, and you will see that the name has changed. So var1, var2, and CORR. So what's the next step? Let's start drawing our plot. As usual, we start with ggplot, and we need to say what data we are taking. We are not taking the df, but we are taking that column that we have just worked out. Column. The default data that I'm using here is column, and we are going to use the aesthetic features, where x equal to var1, y equal to var2, and then because I'm going to draw a heat map, I need to use this fill that will fill in colors based on the correlation that is computed, as you would have seen here. I'm renaming them as core. Otherwise, you would have had to write fill equal to frec. Like here, you would have had to write fill equal to frec. But here, because I've changed the name, So fill will be filled with those values that you have here, all right, based on those values. And then we are going to do plus, just like we did earlier, geometry. I think this is quite simple. You would have understood by that now. And then we will need the geom text again, just like I did earlier. And the germ text you want to include, rather than including like in the previous case counts, we are going to include label equal to the core here. These are the values, but the only issue that we have is that if we put this as it is here, there will be too many how do we say, decimal places that will appear on the style. That's not very neat and nice, so we might want to round it right from the start to the nearest two decimal places, and that's what I want to do now by doing so. Okay, and then uh, normally you can also include a size as well for the text. You can say size equal to free, just for information, or you can leave it as it is. I did not explain that to you earlier for this one. You could just do the same thing there to increase the size of a text. It becomes three times what it is supposed to be. By default it is one, obviously, but here if I put size equal to three, the text will grow, will be bigger. But you can leave it as it is. By default it is one. And then let's put the labels, and then the labels is title equal to, and then correlation heat map. Okay, correlation heat map. And then the variable x, you can call it, because you see the issue here with the variable x, you don't really have you will have the name of the variables in the matrix down there, but I can't just call it var1 and var2. That would not make sense. So I would rather replace this var1 and, for example, the channel and segment, I replace it by blanks. That would make more sense in that particular context. All right, so I would say x equal to, and I will say y equal to blank, because there is no particular label that should define this. I can't say var1, var2. That doesn't make much sense normally when someone will look at that. And then, as usual, plus theme classic, as you see here. Can you give this a try? So object code not found. Let me just run this whole thing again, because I think I forgot to run the rename. So let's find out where the mistake is. Just give me a second with you. Code not found. Oh yes, that should work like this. Okay, normally the rounding should stop here, and the size, let's just check that again now. So the label stop right here, the size become 3 here. Okay, so the label is equal to round core 2, and the size 3 should be like this. The rounding goes for that bracket, goes for that bracket, that label goes for let me just check if this is okay now. Yes, there is something that I missed here, is that I forgot the information that you need to include here. The aesthetic features, all right? So I forgot that part here, sorry. All right, you need to put in geom text, you have to pass on different parameters. One of it is a label round core, which is normally part of the aesthetic feature that you have. And then, because it is, why do we say that it is aesthetic feature? Because it is where you are going to position your label, right? That's why you pass it in AES, because it's where you're positioning your label. Then, independent of the positioning of the label, you have a size equal to 3 that is separate, obviously, as you are seeing. And then we close one of these. There is no need for an additional bracket, because that closes the geom text. In the geom text, you have the aesthetic that brings the positioning of the correlation where they are going to be labeled. in the graph and the size, obviously. So let's run this again. Now it works. Here we go. We have our correlation map, and maybe there is one thing that you want to change, just like I did earlier. I would put in the geom text an additional information, which is going to be white. Okay, I don't want these black because on blue, maybe it will be better if I put it as white. That would be better normally. Let's run that. There we go. I think this is clearer. So what does this correlation matrix shows you? The closer it is to zero, the darker it is. The closer it is to one, the lighter it is. So in other words, you see that these dark shaded regions shows very small correlation, but those blue, pale blue, shows strong correlation. So what are those variables that has strong correlation? You can already see a group already here, the 0.86 here, that is income and expenditure, which has a strong correlation. Obviously, this 1111 is not really relevant. You don't need to worry about that. But what matters here is that we see that there is mainly one variable for which there is a strong correlation between these two, whereas the others are moderate to small. Like, for example, satisfaction and tenure months, the relationship is almost inexistent in terms of linear relationship, I mean. Like here, income and tenure month is not, these two variables are not associated. As you see here, in terms of linear relationship, they are very small. Okay, here we go. That was how to draw correlation heat map. When we are doing exploratory data analysis, it is good that we come up with graphics as we have been doing extensively so far, but it is also good to have some numerical measure as well sometimes. So what I want to do here now is to compute for the last thing for today is to compute the correlation for this part of the video. I mean, is to compute the correlation for one pair, that is an overall correlation, but also by segment. I want to compute correlation, for example, between income and expenditure overall, but then I will do it by segment. That is the correlation between income and expenditure for different segments, that is budget, premium, standard, things like that. Okay. So the first thing is I will come here and I will do overall. Let's call it overall R. And to do correlation, it's very simple. You just need to type this function COR and then df dollar income, because I did not attach the data frame yet. So that's why I'm using this dollar. And then I can do spend. If I attach this, there will no need for me to type dollar each time. So let's leave it as it is. We run that and you can just check the overall, which is 0.86, which we already computed anyway. That's fine. So if you want this, you can type overall R here. You get your result, obviously. Now I want to do correlation by segment. All right. The relationship by segment might differ by groups. That's why we want to do relationship by segment, because the relationship may differ by group. For example, premium customers might show a stronger income spend link. Budget customers might show weaker relationship, you see. So you want to know and discover all this. If you want to do that, you can do you can create you can do a summarization on your data frame. You can do a summarization on your data frame. And to start with, we are going to apply the piping operator here. And then what do we do is that we will say, in that data frame, start by grouping different segments together. That's what I do by group by. And then I put segment. You already have a variable called segment. You would recall that. And when I have done that, the next step would be, when I have already segmented the data, my next step would be to summarize and obtain the correlation pertaining to each of these segments. To be able to do that, I will need to use a function called summarize here. And that summarize, it will compute the correlation in each group. So the group by, it split the data set into groups. The summarize will enable me to compute the correlation in each group. So what do? I do summarize, and then I give it a name, because when I'm going to get the data, the table, I want to have a name that is as explicit as possible. The explicit name I can call is R income spend. R income spend means you are going to compute the correlation between income and expenditure for each of these segments separately. To do that, we do go, and then I will repeat the same step, go spend. That's all. So when I'm doing summarize, that will enable me to compute the correlation and spend not for the overall income and expenditure, but by this group segment that I have computed here. All right, that's what I'm doing here. So let's run this, and here we go. We got a table, and the table is budget 0.648, premium 0.69669, standard 0.616, and as you are observing here, there is not much difference between all of these relationship, right? Standard seems to be a little bit slightly lower, but not that much different. So in that particular example here, the relationship does not necessarily differ much by group, but in none other context, this relationship may differ. So that's all I wanted to show you for the first part of the lecture using R. Just for your information, whenever you have an assignment or something to do, you might have not only to do graphics, but also to compute some summary measures, as I've just shown you as well. So you need to explore your data to the maximum to be able to understand better what's going on and interpret also what's going on. That's all for the first part. So we'll meet again for the second part of the video, where I'm going to do the same thing, but in Python. Thank you for your attention.